Welcome. Are you in the right room? We're going to talk about some Opentelemetry, some open source stuff. All of this is going to be introductory level. Welcome, come on in. I kind of wanted to get an idea who I'm talking to, so how many of you are students here? None of you. I was told students were coming. I guess I scared them away. Developers? Hold them up a second. Okay. Architects? 2. Managers? 3. A couple of managers. What are you doing here? I'm just kidding. I always play with you like that. Of all the people in the room, how many people are in IT less than 2 years? 5 years? 10 years? 15 years? Oh boy. 20? The rest of you? 30? Jesus. My gosh, man. Okay, so you're at an introductory open source. That's kind of interesting to me because usually this is something you get into when you're a little bit younger and stuff. How many people have been working in open source at all? For your whole careers or? All right. Anybody working with Opentelemetry, anything like that in the observability space? So you know all about Opentelemetry. Why are you here? Just making sure I'm telling the truth or no? All right, what are we going to talk about today? It's pretty straightforward, pretty simple. I'm not going to try to go too deep technically. It's an introductory course. We're going to get a little bit of background on cloud native observability. You notice that weird term? Does everybody know what OLI is? Everybody know what Kubernetes is? You know how sometimes they talk about K8S? You know what the 8 stands for? Number of letters between the first and the last, right? Same thing with observability. Now, I used to work at in the app dev space, and now I work in the observability space. I get really tired of, everybody gets tired of typing that into stuff, right? It's really long, it takes up too many things on the social media, it's a pain in the butt, so everybody calls it OLI. Don't get panicked, that's all it is. The big deal about observability is not just doing observability, but doing it at scale, and what that means, right? So when we start going into the cloud and cloud native and do the stuff at scale, it gets really impactful in a lot of ways that most people are not aware of, including the companies that have been doing it for a while, right? They're finding out the hard way really fast. Nuts and bolts, we're going to go a little bit into what's inside of Opentelemetry, not super deep, don't worry, you don't have to break out the laptop and start coding. But to give you an idea of what you're going to find inside there, where it's positioned in an architecture, what it can do for you globally, right? Just, you can dig into it later yourself. Just so you have an understanding of what you're dealing with with this thing, and don't try to position it in the wrong way inside your architecture if you want to explore this stuff. And then getting your feet wet is not so much about how to contribute to open source, because I think you can figure that out and there's enough talks about that stuff. But in this specific case, how you can engage is, I think, a little bit more important, and a little bit how it works around the CNCF, which they're a part of. Also, if you have any questions or anything, feel free to stick up a hand. I got some pretty bright lights in my face, but if you hold it up long enough, I will find you, see you, unless you're sitting right there or right there, because you're really in the lights. You might have to wave at me a little bit. Yeah, so that would be a good idea. So, cloud native observability / at scale. So I think this ice cream pretty much says it. How many people here work with cloud in their work every day? So like, you know, actual cloud providers logged into that stuff. It feels like you dropped your ice cream, right? They promised a lot of stuff. Everything's going to be fantastic. I don't have to maintain stuff. Since we have such a mature audience here in the IT space, we all remember the days where we did everything on a laptop, right? When you first started developing, everything was here locally, your servers, your Java apps, whatever it was you were doing. It was fantastic, right? You had control over everything. When you deploy, okay, you throw it over the wall, and the operations on whatever floor in the building was at, they would get this stuff and move it to the next VM or the next, you know, data center piece or whatever it was. When everything goes up into the cloud, it's supposed to be really easy. It's just entries in my IDE, and everything's supposed to be fantastic, but I feel like this too. It's like my ice cream fell on the floor. They didn't really come out with the promises all the time, right? Initially, when you get in there, it's super easy, right? Everybody know what a container is? It's not these, but it's just for the image, right? Building a couple of containers and getting started on your laptop and moving that in a small organization over onto a platform like Kubernetes, whatever cloud you're using, not that hard, right? We all get our heads around that really quickly. We start pushing this stuff out. It seems like it's okay, right? Not a big deal. When you start looking at what is happening in the cloud, and I'm easing a little bit of the OLI stuff in here, I Googled around a little bit to find like just an example application, something really simple. In the speaker notes, also this slide stuff is online right now at my website. It's mylastname.org. So you can see the speaker notes of this stuff. Linked to this example itself. It's pretty representative for what I could find. I found several examples. This is roughly, it's well documented anyway. It's just a hello world app, very simple, like a front-end website thing. He generated some hits on the front end like some users might be using. Nothing dramatic, just really light loads. And then he put all the metrics you would do around that stuff to collect and look at it. So like end user metrics, the actual app metrics, the nodes. It's a 4-node cluster on Kubernetes, that's it. What do you think happened? How much data got generated around this? And I'm not talking about the data that you're doing as a business. I'm talking about the data around the infrastructure that you're collecting. 0.5 terabyte. 0.5 terabyte. Think about that. That's not a scale. That's one. How many apps are you running in your company? You know what I'm saying? So just keep this in the back of your mind a little bit, right? This is why the ice cream ends up on the floor. On top of that, when you're talking about observability data, what most people as developers don't think too much about, we don't care. You know, you want me to put some tags and labels and instrumentation in my code, no problem. On average, companies have to keep this or are keeping it for 13 months. So that 0.5 terabyte is being kept 13 months for each one. That's just 30 days of collection. That's all it is. A lot of them don't really think about this until they start seeing the bills and they're like, shit, what can I do about this? One of the things you can do is think about, instead of having, and we're all running really fast, like when the pandemic hit, places like DoorDash and things like that exploded, right? So their infrastructure exploded underneath them because everybody was rushing at that stuff. And so it auto scales up. You start storing all this data, you start getting the bills in, and you're like, hey, wait a minute. But what about those training environments that only come up for 2 weeks, right? Somebody spins up a course and is working on it for 2 weeks and it goes away. If you're just running around doing all this stuff, you don't have all these fine-grained plans in place. It's just a policy across the organization for 13 months, right? Instead of saying, hey, maybe this environment only needs to be for 2 weeks and we can throw that data away, right? Or not keep it at all. Maybe we really don't care about the training environments. Something to think about. So those 2 containers, as you grow, start turning into something like this. A lot of containers, huh? A lot of areas of your infrastructure are getting filled up. Maybe you're using multiple clouds. Maybe you're using some local stuff. Each one of those cranes, think of that as a piece of tooling you've added around this. So it starts to get really kind of big, right? Cumbersome. You have DevOps teams you've started scaling up. Is anybody here doing DevOps? Only 3, 4? Y'all lying. You're trying to do DevOps, maybe. Maybe you're doing DevOps, maybe you're not, whatever. But the idea is that you start melting these teams together, you have processes in place where everybody's kind of helping out across all of it, right? The thing is to get your head around this stuff and start growing your observability infrastructure around it. Now you have on-call stuff, right? Anybody here carry a beeper for their work? Or do on-call stuff? 1, 2, 3, 4-ish? Is anybody an SRE? This guy right here, y'all should buy a beer. This is the hardest job probably in IT right now. Do you agree?
Yes. I mean, well.
It's a loaded question.
Yeah.
It's a loaded question. A really fun story, I hope she doesn't mind. I work with a lady that I hired here that spent 6 jobs as an SRE. That was her first. She transitioned out of something completely different into IT and thought SRE would be fun. She burned out 6 times. Right? And the last time when I finally met her, I said, what are you looking to do? Go to get the 7th burnout? Or how about you come over here and start taking all these great things you've learned and all these things and share back, right? Do what I'm doing, teach people. And she's now on board doing that. And she has amazing stories. Ask him. I bet you have all kinds of cool stories about when it didn't go well or what happened and how you fixed it. And these stories are golden. It's really, really, really educational to talk to people like that. One of the funniest answers when I ask this everywhere I go, that question. One of the funniest answers I ever got was the guy said, I do an SRE for a while and then I go back to development. When I'm tired of that, I go back to SRE. So he wears it off before he'll go back. So it's sort of like when, I think when women have babies, like they forget all that pain and then they have another one. You know what I mean? It's like, I hear this from my wife all the time. It's not my story, but it's how we forget the pain to go and have a second kid, right? I think it's kind of what he was doing. It's kind of funny. But again, back to this, cloud native at scale. It's hard, right? You start finding out how hard this is. And yeah. So when we look back at the simple containers, the OLE, the observability you're setting up, the monitoring is pretty easy, right? The view is wonderful. Everything is easy to understand. You might have a single pane of glass, you know, the big dream that everybody had. One place to see everything that's going on. You'll have a DevOps rolling. Everybody's pretty happy. Everybody understands the infrastructure. The on-call things aren't too bad. You know, something goes down, everybody knows how to find it and fix it. But when we get to that large-scale stuff, and it doesn't take much to get to this. I know this is a super extreme image, but it's not hard. It really isn't. She didn't burn out 6 times for nothing, you know? There's lots of reasons for that. I won't go into that, but what you're seeing here is people are going on call and getting burned out. You see that if all my DevOps teams are over here working and doing the dev and the ops like they're supposed to, and the new business and all that, and then you start developing your own OLE infrastructure, your own observability stuff, more and more people from this side are being drug over to this side to maintain this, and that's not what you signed up for. You know, I don't know any developers that really love triaging issues. Really funny thing I did for a different talk was looked at a developer's time they spend, and if you kind of Google around, look at some of the stuff that they do in Gartner for reports and stuff, this is kind of with rounding errors of probably 5%, but 50% of their time is spent on, 50% of the time is spent on issues and triaging. Around 18% of their time is spent on coffee machine, lunch, meetings, whatever you're doing. And 32% of your time is spent on actual developing new code. You know, doing shit you want to do, being innovative, what you signed up for, what you study for, the reason you love what you do. And that's super painful that 50% of your time is doing stuff you don't want to do. We actually have an observability report that came out that we had independently researched at Chronosphere where I work, and they had 32%. We had 500 developers and engineers answer this thing that are actually working at large, born in the cloud organizations, and 32% of them said that this is affecting their personal life, that they're not happy with what's going on, and 29% wanted to quit. Jesus, I'm sorry, but isn't that nuts? You know, I mean, we're not really surprised if you look around you, you know, and you've been in one of these organizations. I mean, not everything's on fire. That's not what's going on. It's just super complicated, right? And things are very fast-paced in this world. They're scaling out of control really quickly. So you can't get your head around all this stuff. Really interesting that I watched, I believe it was an IDC talk on cloud in Europe. It was a Europe report. And it was over 80% of companies last year were going to have a FinOps role by the end of this year, which is a huge number for an analyst to put on a piece of paper. That's huge. Usually 40%-ish is already a trend, right? 80%, like they can't control these costs. They can't figure out what's going on. The bottom line is water through a pipe is where it's coming from, but it gets a little scary. And what's really remarkable is they're seeing really directly that spend. So when you're here at what I'm doing as a business and my data and my spend here to make whatever I'm doing with my customers, and you're watching this go like this, and we see it time and again at customers. It's crazy. Question?
Yeah. So are you, since I guess you're in Europe
Yes.
most of the time, the company I'm in, where I'm an SRE, they not only is it just very chaotic, and I'm in that kind of burnout phase that you're talking about, but then we're also fully remote, which seems to compound it because it sort of feels like, you know, I feel very untethered, not seeing people, not getting coffee, having the banter. Is that something that you're seeing as well in your environment? Because it just seems like everybody's like sort of used to being a walking wounded person.
Okay, because we're live streaming, I'm going to try to repeat that question. So we have a gentleman here in the front row who is our SRE in the room, and he's saying that he can identify, I'm just trying to, consolidate this. he's seeing that the burnout and the stuff and the chaos that I'm describing, and it feels like he's, because there's so much remote work going on, that he's untethered with, contact with people, and feels like he's drifting around in this problem space. Roughly right? And am I seeing more of that? For sure. I don't think it's necessarily being untethered in the sense of being remote only. There's a lot of that going on. I think what a lot of SREs are feeling, and it's a traditional thing. I mean, I honestly went through it when I first started at a bank I was working at, where you do your code, you throw it over the fence, and they come back and say, I see all these Java exceptions, I don't know what the hell this means. So you have to run down to the 3rd floor and go look at the stuff over their shoulder and trying to figure out what's going wrong to get it to work in the test environment so we can push it further in the production process. Maybe face-to-face would help a little, but I think that not listening and being overwhelmed with what we're talking about is a problem. That's my personal take on what I'm seeing. I don't know if that resonates with what you're feeling, but yeah, it's hard, right? It's what everybody's looking to fix, and when you look at that, the problems that are going on. Let me jump to the next one. This is possible, right? There are places that have done this. So this is a picture of a well-organized infrastructure, right? You even have some special project that are really nice, that are run really well. When you do this stuff at scale, it's more about taking the data and all this information you got coming in and quantifying what you need and aggregating away what you don't. So instead of having that big flood of stuff coming in and paying for all that and having this problem, you're now reducing the thing down per section of your organization, per team, has a dashboard, has the information they need. And you need tools in place that can do this, and you need processes in place. You're seeing things like platform engineering being defined and expanded. You're seeing SRE teams being defined and expanded. You're seeing centralized observability teams. You see layers of observability and control coming over the top of this. You see FinOps being put in place. I'm not saying it's easy to do this and everybody always has it under control, because you don't know what's going to happen tomorrow at that scale. All of a sudden something explodes like GameStop. That's a US-based relevant example. And Robinhood, who's one of the trading platforms that was involved in that, just exploded. I'm sure their infrastructure went whoosh, when everybody started piling on top of that. You hope you have stuff in place like this. Anybody know where this is?
Barcelona.
That's not fair, you've been in. I was going to ask all the Americans and see what they say. Yeah, this is Barcelona. It's pretty crazy. When you're walking around, you don't feel like it's that organized, but when you come in on an airplane, pay attention. It's a beautiful city. So we're going to slowly start diving down into the information we want to get into around telemetry and observability in the Opentelemetry space. So I wanted to give you a few definitions so we're all speaking the same language and kind of know the right area we're doing here. So basically, telemetry is collecting, remote systems information, really broad, right? Anything it'll give me, I'll take it, right? You have different areas such as, metrics and things like that that are quantifying this space, but that's all telemetry in theory. All good? Let's get down into some of the nuts and bolts of what Opentelemetry is doing. This is a project that's been around for quite a while. Well, not super long, I guess, but for cloud space, it's been around a long time. If we kind of go back, and I can get these dates right, it's all in the speaker notes. I think around 2014, Kubernetes came out, right? Immediately behind that was Jaeger. That was the first kind of complete platform collecting, telemetry information in the open source world. In the CNCF, it's a graduated project. It's fully, functional. Behind that came things like open tracing and a couple others. Attempts to kind of quantify this specific space where we're talking about microservices, where you have a really disparate bunch of things going on in your infrastructure, and you want to figure out which call went where and how long and what happened on the way. You're basically, it's a complete complex distributed system. And collecting metrics and telemetry information around that was kind of a new thing. It's really hard. I had friends that used to do this for companies, and they spent a lot of time trying to figure out what was going on in the testing environment, trying to find the good practices around how to do this. I think it was 2019, they merged these all into Opentelemetry. Just one thing, one project, one push forward. It is not a graduated project yet. It's on the way. It's in the, I think the second phase is the incubation phase. Go check it out. Beautiful documentation, really good getting started. It's really nice to have developer and ops divided so you can take paths through the learning thing in the beginning. It's pretty neat. What it is not, anybody here heard of Prometheus and Jaeger and things like that? Those are actual platforms where they collect, you know, all of it. They store it, they're the whole back-end stuff. This does not have a back-end. So what it's doing is generating stuff on the front end and pushing it to any back-end you want, in theory. That's the idea, right? Just want to be real clear on that because a lot of people jump on it and they're like, ooh, we got all this nice stuff, but you have to have a back-end already, have some kind of metrics collection on the back-end, telemetry collection. Now getting a little farther into the telemetry in this space, these are basically the two things you're going to hear about. You're going to hear about traces and you're going to hear about spans. So a span is a single unit of work. It gets defined. It doesn't really matter what the details around that are, but think of like a name and address, that kind of thing. And then a trace consists of multiple spans. So a really simple analogy for you, all those microservices out there, a span would be a hop from one to the other, and a trace would be the complete path it took to get the answer back to the customer. We'll look at what that looks like a little bit later. I owe you that one yet. What's inside of Opentelemetry? There's a specification. It's pretty straightforward. You have an API that it works against. Everybody loves APIs, right? We have a contract. It's very simple. We understand what we could use and what we can't do. You have SDKs. These are the things to use for language-specific tasks. A lot of the auto instrumentation has approached this through SDKs. If you have something special you want to do, you can go get one for Java and do something special, right? You can add more stuff to it. And then there's a special data specification. It's called the Opentelemetry, I believe, language protocol, the OTLP. Kind of funny because I'll come back to it at the end when we talk about how to engage. There's a special interest group right now that's working on a specification across all of this landscape about how to describe this protocol that we're doing with telemetry in general. A little bit more broad than just this. This is very specific to tracing telemetry data. So what does this look like? Everybody loves an architecture, right? Very simple without getting too detailed into what's going on. The three things I just described you see are inside. I'm a Java guy from the old days, so I use Java in my examples. Anybody here a Java developer? You'll have a job forever, right? That's my plan when I retire. If I get bored, I'm going to do some Java stuff like the old guys used to do COBOL at the bank, right? There's so much Java out there. Anyway, auto instrumentation is the one that's really great, right? It's just you load that library dependency or whatever into your language, and it'll self-detect in your apps certain basic things around telemetry data. You also have the ability to do that by hand. You don't have to do it with automation. So if you have specific tags and labels, I've mentioned it multiple times. I don't care as a developer when my specification comes in and they want me to put labels and tags and stuff on it, I'll do that. You know, I don't care if I'm blowing up at the other end my bill for the month. It's not my fault. Somebody else asked for this. You see the API and the SDK might be involved or not. And then you have a collector. It's basically running on the same node and it's just collecting this stuff, right? We'll talk in a little bit about the magic inside of that collector. It's using the protocol to push this stuff as it does for each one of these traces, each one of these spans. It's collecting all this stuff and pushing it out in some form or another. Now, we didn't have a back end, right? So now we need to add a back end of some sort to actually collect this stuff. Where's the collector going to push it, right? And you still see we're using the really basic agent. There's two ways you can do it. You can do an agent or a gateway. We'll look at the gateway in a second. The agent is on the actual same place that your apps are at, right? Sidecar, that kind of thing. If you're doing Kubernetes, I think it's called a daemon set, whatever. You know, details, you can find that in the documentation. Using the protocol, it's pushing all that stuff back out to whatever backend you want. The backend is needed because that's the time series storage, right? We need the storage, special kind of database so we can query that stuff and produce dashboards and all this fun stuff, right? Your day job, right? Very much so. I'm not lying yet, am I? Anybody checking up on me? All right. So if we get to the point where you're going to use a gateway, this might happen when you start getting really big, right? You're going into the clouds. You do it per cluster, per data center, per region. You add a collector. It's basically the same thing as the agent. It's just collecting a bunch of agent stuff together. It's another layer of abstraction. Think of a gateway of some sort, and it does the same thing, pushes it to the backends as you wish. All right, everybody on board so far? Good. Now let's get inside of what this thing does. Very simple, 3 things. It's got a receiver, so it's collecting the stuff you're bringing in. All lovely, all great. It's passing it off to a processor, and the processor is where the fun starts. So you remember I was talking about all this flood of data you have and stuff? In this processor, you can define what you want and what you don't want. So by hand, unfortunately, not a lot of help there. You can go and decide what you want to keep and what you don't want to keep. You can decide what you want to aggregate. You can decide whether you want to set up a preprocessor or a processor to turn your traces and spans into some kind of metric data, right? Specific to Prometheus, for example. There's a lot of examples around this stuff that you can go, and there's a bunch of stuff you can plug in there. And then you have an exporter. So after we've manipulated everything, we say, exporter, send it back. So the exporter is basically designing how, or used to say what backend I'm using, put it in the format it wants, and sends it to it. I'm pretty sure there's exporters. There was actually a bit of a hoo-ha about one of the closed source vendors manipulating one of those exporters, one of the maintainers of the exporter, about making it so easy to push open source stuff into their backend. So go look that one up or ask me in the break. I'm not gonna, because we're live streaming, I'm not gonna hit on anybody, but it's a good example of open source and what happens when you don't play nice, right? But these exporters there's a huge collection of these things. So you can use almost anything you want. Most of the examples I put in there are just the open source stuff you'll find at the CNCF, other projects, some big, some small. It all works pretty seamlessly. Any questions so far? No code yet, eh? Oh, we got one. Question.
Is the direction of the relationship between the collector and the backend inverted in some cases? I thought Prometheus was polling rather than receiving pushes.
Yeah, so the question is my drawing lying? If I can summarize. That if you're using Prometheus, for example, as a backend, the guy that asked the question thinks that you talk about scraping, it scrapes. Yeah, there's push and pull, yeah. It depends upon how you define it. So for example, if you're using a Prometheus exporter, it would be scraping that endpoint. Basically exposing, and it's kind of technical, you're exposing an endpoint and you're scraping that, yeah. Anybody here use Prometheus, or all of you use Prometheus? Not too many. Prometheus basically exposes an HTTP endpoint, and it's called something /metrics, and you can actually open it in a browser and it dumps everything that's basically the APIs you can query, right? So you can see all the different calls and metrics you can see. So that's what it would do here in that case. It would expose an endpoint like that. Answer your question?
Yes.
Good. I got one down here first, and I'll come over to you.
Yeah, I actually had a similar question around push and pull. How would you decide what other scenarios use push versus pull?
I think your backend, so the question, again, the question summarized is, again, about backends pushing or pulling. How would you decide which one to use? I think your backend pretty much decides that for you. Prometheus is scraping targets. That's just the way it goes. I don't know if you have an advantage either way. It's just what it does. I do know that the reason that Prometheus does the scraping and does to go get it and bring it in is that it has the least amount of impact on your existing applications, right? The idea is not to put the load there, to put the load somewhere else. Answer your question? Yeah. Another one.
What is the messaging format? Is it JSON, XML, or both?
So the question is, what is the messaging format for the OTel protocol, I'm assuming? Mm-hmm. To be really honest, I haven't dug that deep to check all the different things you can do, but if it's like Prometheus and all the other ones, I'm assuming it's in most likely YAML and JSON, for sure, if not others. I think the only exception will be pushing towards the back end with exporters. For example, if you're talking to something like a proprietary whatever that has their protocol that's been implemented there, so there will be some translation. The processors will take care of that stuff too. So, answer your question?
Yeah, and I'm just curious, are there challenges with masking sensitive data?
I was waiting for that question. So that's the question of the day. How do you mask sensitive data? That's exactly what those processors are for. So one of the things you do definitely want to obfuscate is, any kind of client-sensitive stuff before you export it across regions. You don't want to have, and there's countries in Europe, for example, where you're not allowed to export data across the border, private information and stuff like that, GDPR stuff. That's definitely where you would scrub it before you send it out. Another question, front row.
How do you correlate data across spans?
Across spans, how do I correlate data? That's a good one and a very long answer, right? Using your preprocessor is the short answer. If you want to talk to me offline, I'm happy to discuss this after this thing, just because it's a more deep than this, You're not sandbagging me, are you? No, that's a valid question, but I mean, it gets very technical, right? So we can chat about that in a bit. Yeah, I don't mean to waffle them off, but that's just time constraints, right? Okay, here we go. So his question is kind of valid for this slide, right? So how do we correlate this stuff across spans and traces? There's two views on spans and traces here. The one with the tree is basically saying each one of the nodes is one of those spans, one of those individual piles of information we're collecting. And when I look at a complete trace, that's what the trace looks like. I think for human consumption, the time period one is a little bit more easy to consume. You see that the A represents the entire trace, but we can also look at individual spans inside the trace, so B, C, D, E, and whatever you're collecting. Pretty straightforward, right? Not too technical. But you could see the question he's asking where the technology is going to get a little bit more complicated when we want to correlate across these things, right? And a really short answer for you would be you're going to start poking at the spans more so than you're going to build a new trace with spans, right? Cross traces. There's also a Kubernetes operator. So is everybody familiar with operators? We're all pros, right? No, not at all. Okay. We got 2 pros and the rest are kind of shaking their heads. So an operator is a way to spin up a container that's already predefined. So as you see in this picture, I can spin up replicas, right? Just they're all the same, or as you also notice what's inside there is an auto implementation aspect, which means language specific, right? So one of these might be Java, one might be Go, one might be Rust, one might be whatever the hell you're doing, Python, I don't care. But they all contain these tools inside there, and all you're doing is taking whatever code you're going to run and pointing it at the, hey, put this inside this container for me and spin it up on one of my things so I can collect 0.5 terabyte of data in 30 days, right? That's the same idea. Basically limitless. When something happens to you, for example, when you're doing the DoorDash explosion during the pandemic, you're going to see this endless pile of containers spinning up. Operators just makes it really easy to use predefined stuff so your developers don't have to do a lot of legwork themselves, right? It's not very hard to do. So the last section here, I think we're relatively on time. Getting your feet wet. So again, like I said, we went through what the space looks like, what observability is, what observability at scale means, the nightmares, the horrors. We heard some of the stories and questions. And then we went into what the project is, and now we're going to look at how you can get your feet wet without talking too much about, hey, committing code and finding that first issue collection that they have and that kind of stuff. I'm sure you all can figure that part out if you want to get that far down the road. But what's a little bit more interesting is engaging within the CNCF or inside individual projects, right? And what you see here is a Slack channel. They're pretty big on the Slack stuff. All I did was search, I think, here on Opentelemetry, if you can read that. And there's just all kinds of groups and stuff going on. So the minute they start digging into something new and they have a sub-project or whatever going on or a specification they're working on, you can find a group about it. They have calendars where they list meetings you can attend. You can see recordings of those meetings if you can attend. That happens to me a lot because I'm in the wrong time zones. Very interesting to see what's going on. You have very, very simple stuff like the hallway where people just talk about all kinds of stuff they're doing. You have a social media channel where people post what they're posting that's relevant to this specific project. These are really easy ways to start having chats, and you can even learn without saying anything. You even have channels where they drop in like, I'm having a problem with this piece of code, why doesn't it work? I'm not, who doesn't love the guy that goes on Slack on the channel and dumps a, exception trace? But I mean, you can live and learn, you know. It's fun to watch. Another big one is KubeCon Cloud Native Con. That's like the premier event that they do for CNCF. They do one every year in the North America and one every year in Europe. If you're coming to the Europe one, it's in my home country in the Netherlands. It's going to be in Amsterdam. You're all welcome to come. I'll give you a tour of the city. I spent 9 years living there, and I went to college there. So even did security there for a while, so I know some places you've probably never been. Happy to show you around. Just hit me up. They're a lot of fun. They're big. They're quite big. They're also very developer orientated, a lot of in-depth stuff around the open source, like what you're feeling here, like what you're seeing at All Things Open. Pretty comparable. We have a front row here, we have a CNCF ambassador, so she can tell you all kinds of stuff. They haven't let me in that club yet. Maybe I'll stop talking about this stuff if they don't. You have special interest groups as an example. One of the ones that's kind of interesting that I'm following right there is called Tag Observability. It's a technical advisory group, I believe they call it. It's just a bunch of people getting together and say, hey, what if we defined a standard protocol around all this metric stuff? And not just specific to metrics, but also how can we do something specific? Not OTEL protocol, not Prometheus stuff, not just one. And it's kind of fun to get in at the beginning and watch something like that evolve, and the documents grow and the ideas go back and forth. So maybe you find something interesting like that. And then you have the ability to get into some of the end user communities. Some of this is sponsorship based. Some of this is just people that are hosting events. So it's well worth kind of poking around and seeing, maybe somebody works at one of these places, or somebody you actually sets up one of these events. It's pretty surprising how big it is. I don't know if you've ever seen the CNCF complete overview picture. People like to put that up there and call it the open source overview. It's got like a gazillion things about this small on it, right? It's so much stuff. So it was hard just to do this to get it viewable for you. And this is the community of sponsors and stuff. It's a pretty big organization. They have a lot of structure in place, so the stuff you heard in the keynote is definitely in full force here. Contributor guides, they're very, very structured in how they do stuff, so you should be able to find a path to help out and to get engaged.